So welcome to our last topic 3 video. So that's the special one. Oh, let me adjust me there. Good. It's on solar application design. So let's see if that works. It's a little bit tricky. I want to show you a software on the internet where you can actually design your location of your solar array. If it's thermal or PV, doesn't matter. So location, then site orientation slope, sun position in relation to the building facade of other buildings, existing obstruction on site, potential for overshadowing from obstructions, and which I think is very interesting in number 6, seasonal solar irradiation changes. So, and here the source www.suncalc.org. So let me see if I can switch that one off. Okay, and get you to my main site, which I hope I can do. Let me see just a second. Okay, trying to get it here. So let's see if you are. I have to adjust it a bit. Good. I think that should be fine for the meantime. So you just put in the SunCalc website, then this will show up, and then you just go in. Let me see. I put already there Ulaanbaatar. That's the wrong direction. So you go for, and I looked at particular, they're using Google Map, and I was looking for a particular location, so it's easier for you to allocate that in the internet. As you can see, the internet is a little bit slowly and is not accepting my challenge here. Let's see if I can. It's coming now. So sorry, it takes a little bit longer, but I think you will have the same problem. I tried to get a little bit more in here. Okay. Maybe it's also wise to just cut me out here. That would be the wrong cutting. That one is the one which I need. So let's go to Ulaanbaatar a little bit closer. I was looking actually for a landmark, and that is the EMART. And let's say, for example, EMART want to put a solar array on the rooftop. And now we want to see if that is, if there's anything in the way, like obstacles. So you can see that's the EMART, and let me go a little bit deeper into that. Okay, I think that should be fine. So I put the location for the PV on the roof of the EMART. Now we have the day May. If you look on the left side, May 22, and we changed this just that you can see what I meant by sun path. Which is the longest day? I think it was June 21. So you can see this is the sun path. It starts, that's the east part, that is the west part. So west is here, east. So it goes already into the, so let's go for the morning. So in the morning, the sun starts from that direction, shining here, and then over the day. So the sun starts around sunrise 4:52, so nearly 5 o'clock, and it's already a little bit light before, and then it goes all the way, and I think I'm in the way now till and then it goes dark. That's around 8, nearly 9 o'clock. So here you have the sun path, and this is actually showing you the shade of if there's any obstacles there. So, but this is not the most interesting date. We have to do to see what would be the most obstacles in the days. Actually, December the 21st. This is the shortest day, and here you can see the sun path is a little bit less. Actually, quite a lot less. I have to get that one. So let's see. In the morning, so sunrise is around 8 something. Let's say we are interested in that wall. That wall is 1.5 meters high. So I will put for the object level, let's see, if it allows 1.5. Let's make it 2 meter. Okay, tag on. So we have the sunrise here, and from here up to that is our available sun path. So we will see if there's anything in the way. In the morning, there is a shade already that far because the sun is very low on the horizon. So it's getting better as we approach 9 o'clock. But you still can see that, for example, that's quite a long shade. So if we would have a panel here, you have to put that let's say distance, and the wall would still shade all the panels here in that direction. That will be nearly off at around noon, so shading is only very limited here. And then if you go further into the afternoon, you can see how the shade is growing again. So this is not only for the wall here, but you have maybe other obstacles. So I think this is a Genghis Khan hotel. It's the same level, height level, I think, but there might be other obstacles around, and that's actually a quite good tool to see if there's any obstacles. And you can see the sun path. You can see in which direction you would orient your PV, and so you can play with that tool. You can use it for your own house at home to see if there's any obstacles in the way if you fancy a PV or solar thermal application. I found it quite useful. I used it in the Philippines and also in other projects. And Google is also updating the maps. So if there are new buildings are coming, but you would, it's I think it's quite interesting to use that, and you have all the data which you would need. For example, sunrise, then altitude, azimuth. So on which level you can see this. For example, the azimuth, how it is changing. Azimuth is this angle here. That is actually the sun path angle. So you can see, oh no, I have to put it there. You can see how the azimuth angle is changing, and then you also have the altitude. The altitude is the angle from the sun to the horizontal surface. So it doesn't go at noon, is normally the highest, 18. We are 18 now, and it's 18.6 till 1 o'clock, and then it goes down again. So it's not more than 18 centigrade, 18 grade. And the shadow length, you can see it here, is 6 meter. If we go in the, that's what I said before, if we go in the morning, you can see at 9 you have a shadow length of 38 meters. If you have something which is here in what I put there, I think 1 meter or 2 meter height. So I think it's a useful tool. I hope I could help you with some design issues maybe at home or for the other buildings. And thank you very much for listening.